Like most conlangs, 0, 1, 2, 3 has the ability to program as your mostly 0, 1, 2, 3 copies Lisp, and where I don't explain something, just assume it's the same as Lisp. Word order is highly important in all programming. 0, 1, 2, 3 is any order, so programming words must be ordered. The listener is the interpreter compiler, calling in a library in 0, 1, 2, 3. The library is code or concepts that someone has already made and established. Bonjour, hello is an idea that is established and perhaps made up of smaller ideas that are not important. It is under the collection of ideas that is French. Python random is the idea. Pick a random number. We know it is made up of other ideas, and those ideas come together in a certain established way that is not really that important to the idea the speaker is saying. It's like saying this person was acting like Gollum from Lord of the Rings. If you know the story, then you have an established idea of what I am saying. Both bonjour and random call in concepts from another language that someone has established their concept. The random library is just an example, and could be any library from any programming language, even if it wouldn't be compatible with other libraries you used. It is just assumed that expert programmers just spent thousands of hours making them compatible and function in the same way reliably. This is because 0, 1, 2, 3 is not a real programming language, but a mental tool to come up with new concepts for your project. A programming function is a question, unlike a normal question where the asker does not know what to expect. It is more of a ritual, where the asker does have an idea of what the response might be. In this way, it is also like a request or orders you would give to a trained animal. You might get a result that you did not expect, but delivered in a way you did expect. Natural language questions frequently have no arguments. An argument is some information that goes in the question. An example of a natural language function with arguments is what is 5 minus 4. This is really saying do the math of 5 minus 4 and give me back the correct response. Question has two arguments. 4 and 5 are both arguments. Notice the order of arguments can matter, as what is 4 minus 5 changes the correct response, but both have an expected response of a number. Let's run through a natural language program. Many may know from childhood the program is the children's game, What Time Is It, Old Witch? For those that do not know the game, the goal is to go past the witch. The players would ask the witch player, what time is it, old witch? If she said any time but midnight, the players could step forward. If she said midnight, the witch would chase the other players and tagging one out and restarting the game. It's a fun, politically incorrect game that I am not offended by. As an occultist, I want to see its deeper occult meaning preserved for history. It is a tactical game of drawing your target closer and striking when the time is correct, the hour when you are powerful. On the other side, it's a game of anticipating what a powerful enemy will do. It's about the dangers of approaching a cornered animal, knowing when to take bigger little steps, surprising the powerful, and sacrificing a teammate for the achievement of a greater goal, and in the end surviving long enough to become the powerful. It reminds of sad time in my faith, when all hunted those abnormal and called them witch. It is a game similar to the way ashes we all fall down remembers a fire tragedy. To erase or change history by covering up the times of tragedy is to endorse those actions. The occult meaning is you as the witch or magic user, even though all are hunting you at midnight. The witching hour, that is when you can fight back and all fear your real power. One by one you can eliminate them with your deadly magic touch, and the last survivor, the strongest, that is the one you should convert. However, if you let even one slip past you, it is death for you. This is one interpretation of the game's meaning. It is not instructions or orders. Enough of that. Back on topic. Why is this a natural language program is here when the children ask the witch, what time is it, old witch? They are not asking the time. The sentence is a function question to generate a random time. Think about it. The words might sound like asking the time, but that is not at all the meaning at all. What the witch says is not the time or even a random number. It is the argument to an implied function that is not named or said. The function function asks to check if the argument is midnight. If it is, then return the action of running, or if not, then return the action of stepping forward. Think about it. Outside the context of the game, the random times do not have any expected response or meaning. The anonymous function could have given back a linguistic response, but it just happened to not in this case. Many of these functions working together is a program. As you're in Lisp, everything superficially looks like a list of data: thing 1, thing 2, thing 3, but these have an implied label that is their location. Thing 1 is first because it is first in the list. Thing 2 is second because it is second in the list. Thing 3 is third because it is third in the list. In 0, 1, 2, 3, everything must be marked because the order cannot matter. Thing 1 is first because it is labeled 1. It does not matter where in the list the word is located. Thing 2 is second because it is labeled 2. Thing 3 is third because it is labeled 3. Everything can and needs to be able to be represented by hexadecimal, so even the parentheses are really two-letter words. 2b for the left parenthesis or for the right parenthesis. 2c, the spiky parenthesis, pictograph, or 0d means end all trailing parentheses. The word 031 is to be read as a programming word. Normal speaking words can be interwoven in programming sentences. Look at word 0. We see that it is a programming word. We also see that its tone level has a percentage indicator. This is a special one, just like the reading direction tone percentage. It is not a percentage but a ordering. So word 0 is 1% word side. This one means it is the first programming word. Notice the speaker has made it easier for us by including the left parenthesis. Okay, now word 1, this has two word side. This means it's the second programming word. We see word 3, this has the two squares. Pictograph, you may not remember this because it's been a while, but this is 50%, in this case 50, and it's on the word side. We see there is nothing lower, so this is the third programming word. Next we see the word 7, this is 99 on the word side. There is nothing lower, and we see nothing else for programming, so this is the end of the programming. The speaker has again included the right parenthesis. So after all that, we have the programming line in order: left parenthesis, word 0, word 1, word 3, word 7, right parenthesis. This could be directly a Lisp line. The sentence also includes a normal sentence. Word 4 is subject, word 5 is verb, word 6 with the anti-verb is the object. Perhaps this is a comment on the programming line or something else to do with the programming line. Okay, let's do a more complicated one. In this we will show that the parentheses are not even needed at all in 0, 1, 2, 3, but it makes things easier to teach. Word 0, this should be easy enough. Its tone level is 0, 1, it is the first word, no problem. Your word 1, we see its tone level is 0, 2, so it's the second word, but we also see an infinity that it has a 0, 1 after that. This means it is the first word inside another set of parentheses. We will call this the second level. Word 2, we see that the tone level first has a 0, 2, that says it's still part of the second word of the first level. Then it has an infinity that has a 0, 2, that says that it's the second word of the second level. Then another infinity, and we see it has a 0, 1, and that this is the first word of the third level. This can be continued to infinity, as many levels as needed. Word 3, we see that the tone level has 0, 2, infinity, 0, 2, infinity, 0, 2, infinity. It's the second word of the first level and the second word of the second level and the second word of the third level. Please look at word 3's location at the top of the slide. See, word 4 only has 0, 3, infinity. It's the third word of the first level. Word 5, because of the 0, 4, it is the fourth word of the first level. Word 5 also 0, 1, showing that it has a second level. Notice that the 0, 4 makes it not part of the second word second level set of parentheses. Word 6 has 0, 4, so it is the fourth word of the first level. Then it has a 0, 2 to show it's the second word of the second level. Then it has a 0, 1 to show it's the first word of the third level. Word 7 has a 0, 4 again to show that it is the fourth word of the first level. Then word 7 has a 0, 2 to show that it is second word of second level. And finally 02. This shows that it is the second word of the third level. Notice the reader never needed the parentheses. They could have filled those in, but it makes things easier for teaching. This is great and all, but if we left 0, 1, 2, 3 here, we would be limited to less than 100 words for the first level. This is how you would go beyond 99. Just keep adding numbers before the infinity pictograph. Now an infinite amount of words can be added to any level, any tone level with the 71 number in it is not allowed. It is my language, and I am putting my foot down. It is my whim that the numbers 71, 7 and 1 together should be banned from the tone levels. This is because if you remember, the 71 is the word for infinity, and so it would end the tone level there. In 0, 1, 2, 3, the speaker must be careful, because there are logical conflicts that can happen, such as this. Don't worry, 71 has a way of saying it tone level of 71 and other conflicts. It's just more complicated. This is form. It is a function question. It is a special word asking the listener to provide the following information in the sentence. Like filling out a form questionnaire. It is the same as tell me, B2 or the lines pictograph. This is a response to argument, so you might say tell me your name, age, gender, political party, and I would reply back. Notice how the tone numbers of the responses correspond to the questions asked in the form question. To make things more clear, this is a programmable sentence with actual high Lisp and Python equivalents. In the top 0, 1, 2, 3, the first word is F and it is the third and last programming. The next word is 0. It is the second programming word. Then we import the Python random function that is the first programming word. It also has the 041 space for the reader to be the interpreter and give the response in the right place. Then the sentence ends. Under the red line is not real programming Lisp-like code. Notice how nothing is mentioned of picking a random hexadecimal number. It's implied, and just works because it's not real. Under the blue line is actual, equivalent, high Lisp-like code. This does the actual work of dealing with the hexadecimal. This will actually work. Below the pink line is likely something more people know, equivalent Python. This line works too. After import random that is not on the slide.